long division. You remember how that worked? You say, does 12 go into 2? No, so you moved over. Does 12 go into 21? How many times? Once. And then you took that 1 and you multiplied by what was on the outside. 1 times 12, you got a 12. And then what did you do?
Subtract.
You subtracted. I'm going to submit that you change the sign. Do you remember when we did this in Algebra? Maybe this starts to ring a bell shortly. And then I'm going to add them together. 21 plus a negative 12. It's just like subtracting. What is 21 minus 12? 9. And then we brought down to 0. How many times does 12 go into 90? Yeah, just take a minute. How many times? 7. 7 times 2, 4, carry the 1, 7, carry the 1, 7 times 1 is 7, plus 1 is 8, 84. And then we change the sign, or we subtracted, and I get 6. Then what do we do with that 6? It's a remainder. There are several things we can do with it. It's a remainder of 6. So did 12 go in evenly into 210? No. Is 12 a factor of 210? No. A factor are things that divide evenly. So 12 is not a factor of 210. It did not go in evenly. Went in 17 times, remainder of 6. We need to be able to divide polynomials. We're going to learn a division algorithm, which just means a method, a process of doing something. Now we need to know some of these names. This is the dividend. This is the, anybody remember? Divisor. Is that how you spell divisor? I think it is. And the answer is the quotient, Q-U-O, there we go, is the quotient. And we already said that that thing is called the remainder. Now, before we get into the polynomial part of it, if I took 12, multiplied it by 17, and added 6, what would that equal? It would equal 210. So right down here, if I have polynomial P and polynomial D, where D is a lower degree than P, it's smaller in other words, then there exists a unique polynomial Q and R such that my original polynomial, that's just like the 210, equals the divisor times the quotient. The divisor times the quotient plus the remainder, plus the remainder. That's all they're saying with this. I can do the same thing with polynomials. If I divide polynomials, then I should be able to take the divisor times the quotient plus any remainder, and it equals the original polynomial. So that's all that big box says in all their fancy language. So let's try to divide. So I have this second, whoa, that's not a second degree. Look down here. That's a fourth degree that I'm going to divide by this first degree over here. So the x minus 3 is my divisor. We're going to put it on the outside. And we're trying to divide it into this dividend that we want to put in the right order. X to the fourth. If I don't have any third degree, I want to hold that position. I want to say I have 0 x cubes, but I want to hold that position. Minus 5x squared minus 8x plus 3. So here's this big old long thing. So let's see the process. In order to divide, I want to look at this x and this first term and say x times what equals x to the fourth? X cubed. So I'm going to put over its like term here an x cubed. And then I'm going to do exactly what we did with the numbers. I'm going to take the x cubed and multiply it by this divisor out here and write the answer underneath. So x cubed times x is x to the fourth. X cubed times negative 3x cubed, negative 3x cubed. Then when we were dealing with numbers, what did I do with this number then?
Change the sign.
Yeah, I subtracted it. But subtracting it is better to think of as changing the signs, and then I can just add them together. It works easier when I'm dealing with polynomials to think of it that way. So x to the fourth minus x to the fourth, that's just gone. 0 plus 3 is 3x cubed. And then when we had numbers, what did they do with the other stuff? I just brought it down. Minus 5x squared minus 8x plus 3. And then we are going to repeat. X times what is 3x cubed? 3x squared. A positive 3x squared, because I want it to exactly match that. So now I'm going to take the 3x squared, multiply it by what's in front. 3x cubed minus 9x squared minus 9x squared. And then we are going to change the signs and then add them together. So the x cubes are gone. Negative 5 plus 9, that gives us a what? 4x squared. Bring down what is left, minus 8x plus 3. And repeat. X times what is 4x squared? 4x. I'll say plus 4x. Take the 4x, multiply by what's in front. 4x squared. 4x is this, negative 12x. Then I'm going to change the signs and add them together. My x squareds cancel. Negative 8 plus 12 is 4x. Bring down the 3 plus 3. And I repeat. X times 1 is 4x. 4, so I have a plus 4. Take the 4, multiply 4x plus minus 4 times negative 3 is a negative 12. Then I will do what? Change the signs, add it together. Those x's gone, 3 and 12 makes 15. Does x go into that 15? No. So that is my remainder. Remainder of 15. Now there's another way of writing a remainder. Instead of writing the remainder, back here with these numbers, I could have said my answer is 17 and 6/12, which of course reduces to 17 and a half. To do the same thing with polynomials, I could have said instead of that remainder, plus 15 over x minus 3. X minus 3. There's another way of writing it, just so that you're aware there's another way of writing it. So this means if I took x minus 3 times this quotient and then added the 15, what would it equal? This dividend in there. Oh, that big long thing right in there. Did the x minus 3 go in evenly? No. So is it a factor? No, it didn't go in evenly. We'll eventually get to things that go in evenly and they become factors. Synthetic division. We saw this in Algebra 2. If I am dividing by a linear binomial, in other words, it's just x to the first, x plus 4, x minus 3, that form. If it's in that form, we can do synthetic division, where we take this x plus 4 and we use the 0 of it, or the number that would make it equal 0. Negative 4 plus 4 would make it equal 0. It's just the opposite sign. And then we take the coefficients. 1, negative 4, I have a 1, I have a negative 4, I have a positive 7, and then this number 15. And if I am missing anything, what do we do? A 0. So I am going to take the negative 4 from my x plus 4, and then I'm going to write the 1, the 0 for the cubed, and then the negative 4, and the 7, and the 15. Now, we start back at the beginning, and we just drop down that 1. Then we will take the negative 4 and multiply it times the 1 and write the answer right there. Negative 4 times 1 is negative 4. And then we will add these together. Really, you can think of starting out by adding them. 1 plus nothing is 1. 0 plus a negative 4 is a negative 4. Then I go back and repeat. Negative 4 times negative 4, and I write the answer there, which is a 16. Add them together, 12. Negative 4 times 12, negative 48. Add them together, negative 41. Go to your calculators. Oh, we can do this. Negative 4 times negative 41. Positive 164, is that right? And then add them together. So there's a 9, there's a 7, there's a 1. This last number is the remainder. And these numbers are the coefficients, just like they started out as coefficients. I have 1x to 1 degree less. The dividend was a 4th degree. The quotient is a 3rd degree. Just like back up here. The dividend was a 4th degree. The quotient was a 3rd degree. It's always 1 degree less. So x cubed minus, and then it just goes down in order, 4x squared plus 12x minus 41, that's my constant, with a remainder of 179. So that's synthetic division. A little shorter, compressed, makes it a little quicker to do. If a polynomial is divided by this, the remainder is the same thing as substituting c into the original equation. This is called the remainder theorem. We'll go through it and repeat what they just said right there. So here they've given us a polynomial. They say use the remainder theorem to find p of c. In other words, we're substituting c is normally the idea, when c equals -2 and when c equals 1/2. But instead of substituting a -2 into the x's in this polynomial, the remainder theorem tells me I can just divide, and the remainder is the same answer as if I would have substituted. So I'm going to take the -2, and it's left as a -2. So I don't change the sign when I'm doing this. And then we're going to do synthetic division. 2x cubed, 3x squared, not missing anything, 2x, -2. So synthetic division, drop down that 2, multiply is -4, adds -1, multiply is 2, add is 4, multiply is -8, add is -10. There's my answer, -10. Now let's check it out. Do your calculators with a -2 up there real quick. 2 times -2 cubed plus 3 times -2 squared plus 2 times -2 and subtract 2. According to the remainder theorem, it's -10. That's what the remainder theorem is. So when they say 1/2, well, I can do synthetic division with 1/2. We can do synthetic division with any kind of number out there. 2, 3, 2, -2. Bring down my 2. Well, what's 1/2 times 2? 1. 3 plus 1 is 4. What's 1/2 times 4? 2. 2 times 2 is 4. 1/2 times 4 is still 2. What's -2 plus 2? 0. Hey, 0 is the remainder. 0 is the answer I get if I substitute a 1/2. A remainder of 0 tells me if I have a factor. If x, 1/2. If 1/2 works, it gives me a remainder of 0. What it really means is x minus 1/2 is one of the factors of that polynomial. And there's my quotient, 2x squared plus 4x plus 4. If I multiplied those two things together, it would be this original polynomial. And this is a trinomial that maybe I can factor, but we'll get there. The answer to this question is just -10 and 0. The factor theorem says a polynomial p of x has this factor if and only if we get a 0 when I substitute the c, or the remainder is 0. They should have said, or the remainder equals 0, because in the remainder theorem we discovered that substituting or the remainder is the same value. Use synthetic division and this factor theorem to determine whether x plus 5, x minus 2 happen to be factors of this polynomial. Well, we're going to use synthetic, they said use the factor theorem. Factor theorem really says we're substituting. So let's take a -5. I'm just contemplating whether I really want to do it that way. Let's take a -5 and let's substitute it in here. -5 to the 4th, and you're going to probably want your calculators. -5 cubed minus 21 times -5 squared minus a -5 plus 20. Did you get 0? Now, it was faster for me and for you to not go to a calculator, but actually, see, I just did synthetic division on it. because we learned the remainder is the same thing as what I substituted in. That's really the power of synthetic division on this. Yes, that's a factor. X plus 5 is a factor. So that was yes for the x plus 5. It went in evenly. Now if I do the x minus 2, I'm going to do it with the synthetic division. What number do I put out here?
2.
A positive 2. And now let's do the synthetic division. I'm just using the coefficients here. 1, 1, negative 21, negative 1, and 20. So that's 1. 2 times 1 is 2. Add is 3. 2 times 3 is 6. Add is negative 15. 2 times negative 15 is negative 30. Add is negative 31. 2 times negative 31 is negative 62. Do you get a 0? That one is not a factor. It doesn't go in evenly. All right. The division of the polynomial by some factor like that, it says the remainder is equal to substituting. That's called the remainder theorem. Check, we learned that. If when I divide and the remainder is 0, then that means this thing is a factor. It goes in evenly. If I divide and the remainder is 0, then we call that value c a 0 of the polynomial. It makes it equal 0. This is just the math terms. If c is a real number, if this thing that makes it equal 0 is a real number, then it's an x-intercept of the graph. We know where it crosses the x-axis. Verify that this is a factor of this polynomial. Then we'll do the rest of it. If I want to verify that's a factor, I'm going to do synthetic division. I'm going to use a 3, 2, negative 3, negative 4, negative 15. Bring down my 2. 3 times 2 is 6. Add is 3. 3 times 3 is 9. Add is 5. 3 times 5 is 15. What was my answer? 0. It's a factor. Had a remainder of 0. And write the polynomial as the product of x minus 3 and the quotient. It's called a reduced polynomial. It's reduced because it's 1 degree down. That's why we call it a reduced polynomial. So how can I write that original polynomial? Well, that original polynomial equals x minus 3 times what? 2x squared plus 3x plus 5. That would equal the original. Since there's no remainder, I don't need to plus anything. That would equal the original. And again, this is now a quadratic, and we have other ways of factoring that. We could get this whole thing factored. I wonder if that's what we're going to do eventually. Oh, I'm done. I was hoping I'd get to do that today, but I guess not. All right.
I think that's okay.